Okay, so this video is for periods 3 and 4 because I will not be there to answer questions. I might be there for a little bit of questions in period 3, but maybe not all of them. And I want to make sure that you have an equal opportunity with my other classes to get answers for your homework questions. So at the time that I am recording this, and I did try to put off the recording of this, I'm looking at my other computer. As long as I could, I have not received any questions from either class about this specific homework, although usually I don't get those questions till like the morning of. So I'm going to base this off of what I got from period 7 today and what I think might be potential issues. I'm going to try to give you as comprehensive a review as I can. And then if you have additional questions or you need to see more, what I'm going to ask you to do is reach out to me, post it on Teams, and let me know what specific questions that you have regarding problems that I might not go over in this review. So what I did was I just copied the homework onto basically the next several slides with the idea that we could have the homework in front of us. So for problems number 1 and 2, all you needed to do on these problems here was write the division. So the goal of those 2 questions is to just demonstrate that you understand what the notation means. So remember with our functions, if you don't like the of x, then not only do you not have to use it, I don't want you to use it. So if you know that you have trouble with the of x, you end up with like x's floating around in your answers, and you get little comments from me in Focus, and you should be looking at those comments in Focus. That say like you've got extra x's in here, that I don't want you to use them. So for number 1, you are simply asked to give me f over g. And so all you need to do for that is function f is in the numerator, function g is in the denominator, and that's it. And then for 2, it would be g over f. So hopefully if I go over 1, you'll be okay for number 2. And again, that is simply assessing whether or not you understand the notation. So for 3 through 8, the directions are a little bit different. You are given different functions. So you are given a quadratic for f and a linear function for g, and then you are asked to perform operations. So this ties it back into the previous lesson with adding, subtracting, and multiplying. So for 3, you would add them together. 4 and 5 are subtraction, and you subtract them in different orders. 6 is a multiplication, and then 7 and 8 are division, where you would divide them. So to give you a review of that, I am going to do number 5 and number 8. And then maybe let's do number 6 as well. Okay, and so that should give you a pretty good, sorry, I don't know if you can hear the noise. There's a club meeting in Mr. Rollins' room next door. It's about 3 o'clock in the afternoon when I'm doing this, so I don't know what they're doing over there, but they're kind of loud. But anyway, so I'm going to go over 5, 6, and 7. So that should give you a pretty good review, so that if you have questions on 3, 4, or 8, you should be able to make a pretty good attempt. And if you really have other questions, again, like post it on Teams at the time that you're watching this. Like don't wait until 3 days later and say, oh, but I couldn't turn the homework in because I had questions. So if you got the questions, I want to know about it as soon as possible. So I'll do 5 on this slide. Because I have a little bit of space over here, and then we'll do the others on the next one. So we've got g minus f, and I probably shouldn't be doing this with the mouse. That's pretty awkward. G minus f, and remember that you can drop that of x, okay? So I'm kind of like scribbling it out over here. If that of x just throws you for a loop a little bit, okay, don't use it. So we're going to have g, which is x minus 1, minus f, which is 2x squared plus x minus 3. And remember, when you're subtracting, you do need to have those parentheses in there. The removal of the parentheses is its own separate step, and you want to be careful about the signs. So you are, the parentheses don't affect the first one, but in the second one, you are subtracting the entire group. So this minus sign is subtracting the 2x squared, but because it's grouped together, you are also subtracting the x. And then for the last one, you're subtracting a -3. The 3 is already negative. So when you subtract a negative, that is the same as adding. So when I go to remove these parentheses, I end up with minus 2x squared minus x and then a plus 3. So there's some other ways you can think about that. You could also think of it as distributing the subtraction. Some students like to envision like a -1 out in front there where they distribute the -1. I will sometimes write it like that if a student asks me to, or if they're having issues visualizing it another way. Now we want to combine like terms. So I'm going to start with the -2x squared. That's the only x squared term we have. And then we have positive x minus x, which is 0. So you could write like plus 0x or minus 0x. I don't know why you do a minus sign there, but we don't really have to write that at all. If it's 0x, 0 times x is 0, and there's no reason to write that in. And then we have -1 plus 3, which is 2. And so that simplifies to -2x squared plus 2. Now the second part of this says state the domain of the result. So if you go back to your notes from last class, I said to state the domain, I want you to ask yourself 2 questions. Is this a fraction and is this a square root? If the answer to both of those questions is no, then probably the domain is all real numbers, which in this case it is. There is no fraction there, and by that we mean something like this, just to clarify, like that. There we go. That the entire function is a fraction, not that you just have to see a fraction in there somewhere, but like you've got x's on the top and the bottom. And there's no square root. And please make sure that you are understanding the difference between squaring, which is what you have going on here, and square rooting, which is that symbol that I'm kind of tracing out with the laser pointer. Okay. So for this one, it would be all real numbers. All right. So let's just come over here. It's the same thing, just I have a little bit more space. So when I'm typing in Word, I am using the little asterisk for multiplication. And if you have a older, actually, I don't know if the newer TI calculators do it or not, but a lot of graphic calculators will also use an asterisk for multiplication. So that's just one of those alternative notations that it's good to know. For me, it usually has to do with the fact that I'm typing in a Word document. And so getting some other kind of symbol for multiplication is pretty tricky. So we are going to do F times G, and you can do this any way you want, but we have kind of a preponderance of people who prefer the area model. So I'll go ahead and do that. So we've got the multiplication there, 2x squared times x is 2x cubed, x times x is x squared. Then we have -3x. And remember what we're finding there are the areas. -1 times 2x squared is -2x squared, -1x, and then a negative times a negative gives you a positive. And then we want to add them all up. So we have 2x to the third, -2x squared plus x squared, which is -1x squared, or just -x squared, which is fine as well. -1x plus -3x is -4x, and then a plus 3. And then the second part of those directions is to state the domain. And so you ask yourself the 2 questions. Is this a fraction? No. Is there a square root in here? No. If the answer to both of those questions is no, then the domain is likely all real numbers. And again, that's kind of like when we use the analogy of your parents putting you on restriction or something. If your grades are fine and you haven't been a behavior problem, probably you're not on restriction. There are some other things you could do that might have gotten you into trouble, but those are the 2 big ones. Some kind of minor behavior problem and getting messing up your grades somehow. So that's kind of what like fractions and square roots are. Like they're the two big ones. If you can learn how to handle the two big ones, like maybe another function will come up that does have a restriction. I mentioned tangent has a restriction, but how often do you see tangent functions? Not that often. Okay, and the last one we're going to do is this one. We'll do number 7. I'll do 7 over here. Okay. And so this is a division one. And so just like the ones above it, it's pretty much just the first part is just a notation. So we're going to do function f, which is 2x squared plus x minus 3 over g, which is x minus 1. And then we, to do the domain part, we ask ourselves two questions. Is this a fraction and is this a square root? Well, this time we actually answer yes to the the first question. Is this a fraction? And so to answer the domain part, we need to think, okay, there is a restriction on this. And so you definitely don't want to guess all real numbers. Like you definitely don't want to guess that. The moment you say yes, there's some kind of restriction. And the key idea here is that we can't divide by 0. And it's so important that you're homing in on that key idea. And not just trying to memorize the process, but you know why this sets up the way it does. It sets up this way because when you try to do something divided by 0, it'll yell at you. So on my calculator, if I do 6 divided by 0, okay, my calculator like yells at me and it turns red and it says can't divide by 0, okay? And so the key idea here is that the denominator can't equal 0. You don't want to confuse that with x can't be 0. I mean, only if x is the denominator, but the idea is that the denominator can't be equal to 0 because you can't divide by 0. In this case, the denominator is x minus 1, and then add 1 to both sides. X cannot be equal to 1. And if you were to graph this, you would actually get something happening at the 1. Like we looked at one of them in period 4, you know, and the graph does something weird when you get to x equals 1. Now I did have a request in period 7 for number 8. So we'll take a sneak peek at number 8. The concept is still the same. So as long as you understand the concept, you know, like once again, you have the denominator can't be equal to 0. Therefore, 2x squared plus x minus 3 cannot be equal to 0. And now because that's a quadratic, that means you now have to work on solving the quadratic. And you just can't forget this. Like if it's stale, but it's got to come back to you. I can't go back and teach factoring again as though it were brand new, as though we hadn't covered it and you hadn't been tested on it. And that's the kind of thing that ends up slowing us way down. So we did go over this in period 7 though. They opted to use the box for the factoring. So with the factoring in the box, we know that the area, we're going to have the 2x squared, we're going to have the negative 3. And then what we have to do is we have to take the first number and the last number, multiply them together. So 2 times negative 3 is negative 6. And I need two numbers that multiply to negative 6, but add up to the positive 1. Those would be positive 3 and negative 2. So 3 times negative 2 gives you negative 6, and 3 plus negative 2 gives you positive 1. And so you can pick either of those. I went with the 3x. And now we basically have just a bunch of GCF factoring. So 2x squared and 3x, we look for the GCF. And so that gives us an x right there. And then we can use the fact that this is an area model. So x times what gives me 2x squared. And that would be 2x. And then, I'm sorry, I lost my cursor. There it is. X times what gives you 3x? Well, that would be a 3. So we'd have a 3 right here. And then last one, what times 3 gives you negative 3? That would be a negative 1. And then you can do, as a check, you can do 2x times negative 1 to get negative 2x, and that matches whichever number I did not pick. So my factors on this are 2x plus 3 and x minus 1. And then what I'll do from this point on is I'm going to kick you back to your notes. So we did do some problems in the lesson and in class that involve the factoring. And so you should be able to find an example problem in your notes that'll take you from this point on. But in case anybody did have a question on the factoring part, at least we made it through the factoring part. Okay, last slide here. This is for the last chunk of problems here, which is just state the domain. And we do want to remember our 2 rules. So I'll try to pick a variety. We will pick number 10, we'll pick number 11, number 13. Let's do 12, okay? So that's a pretty good smattering of problems. So remember our 2 questions. Is this a fraction and is this a square root? Okay. And if you answer no to both of them, then probably your domain is all real numbers. So number 10, is that a fraction? Nope. Is that a square root? Nope. So we would guess domain is all real numbers. And you would get it right, even though at this point you don't know what that little e is. We will cover that hopefully before your EOC. We're going to get to what the little e is. It's a number. But it, like this method is going to work pretty well. Number 11, is this a fraction? And you have to answer yes. And so as soon as you answer yes, then what you want to think of is, okay, well, what is it about a fraction that restricts stuff? And it's that can't divide by 0. So you have x minus 1 on the top, but you can't have a 0 on the bottom. So whatever that denominator is, it cannot be equal to 0. And in this case, the denominator is already factored, which is really nice. So we have x plus 2 times x minus 4 can't be equal to 0. That means x plus 2 can't be equal to 0. X minus 4 can't be equal to 0. So x can't be negative 2 and x can't be 4. And so my domain would be x cannot equal negative 2 or 4. So you have 2 different restrictions. It's kind of like if your parents take away 2 things. They take away your video games and they take away your, I don't know, your television. Okay, or they take away your phone. They take away 2 different things. Number 12, we ask ourselves, is that a fraction? The answer is no. Then we ask ourselves, is that a square root? And now we're answering yes. So if you have to guess, don't guess all real numbers. The moment you see that square root there, you know that's not the answer. That square root is going to restrict it somehow. So don't guess all real numbers. The key idea with your square roots is that the number underneath the radical which is called the radicand, has to be greater than or equal to 0. So you can take the square root of any positive number, okay, and you can also take the square root of 0, but as soon as you get a negative number, then you have something imaginary, and that's when your calculator yells at you. So I'll open up my calculator again. If I do the square root of negative 2, okay, the square root of negative 2, and then yeah, my phone says keep it real. Okay, it turns red, and it's basically telling me that as soon as I have that negative there, that I have some kind of imaginary number. So whatever the radicand is, so if you've got other stuff, like you have a +1 that's outside the radical, and a lot of you on your radical test, you were playing kind of fast and loose with where the radical stopped. You need to know where the radical stops. So the radical goes over the 3x and over the -4. All of that's under the radical. So 3x minus 4 has to be greater than or equal to 0. I'm running out of space. I'm going to kick it up here. We're going to add 4 to both sides. So 3x is greater than or equal to 4, and then divide by 3. So x is greater than or equal to 4/3. And there's your domain. And again, remember the key ideas. Don't try to just out of the blue, cold, just memorize, when it's not equal to 0 and when it's greater than or equal to 0. Like, it makes sense. There's a reason. You can't divide by 0, and your calculator will back you up. You can't take a square root of a negative. Last one that we're going over is number 13. So that's -3 sine of x plus 6. Ask yourself, is this a fraction? Nope. Is this a square root? Nope. So if you had to make a guess, you are guessing all real numbers, and you would end up getting it right. Please remember, don't copy notation that you don't understand. So you have been taught what that funny looking R means. That means all real numbers. But if you're photomathing it or something and they're pulling out some notation that you haven't seen before, do not copy it. If you want to ask about it, that's fine, but don't copy it. So for this review, we went over number 1, number 5, 6, 7, 10, 11, 12, 13, and we did the hard part of number 8. So that only leaves 1, 2, 3, 4, 5, 6.5 problems for you to do, which is means I did more than half of the homework. So this should be a pretty good review for you. Make corrections on your homework and then go back and look at the ones that we didn't go over. Make sure that you iron out any difficulties you might have with those. You are going to be turning this in, but if you have additional questions, I do want you to post those questions or email me those questions during class. So at the time that class is meeting, when you would ask the questions, if I were there. So hopefully this video helps, and I will see you guys next time class meets, which will be after the break.